So today what we are going to study about is n-grams. What is it and how it is used. So in next class, whenever it is, I'll tell you how these n-grams are actually utilized while building a classifier, maybe a neural network model or something. Okay, so let's start. So some basic terms. First of all, syntax. So first is syntax, the allowable structure in the language, basically maybe sentence or phrase, maybe a affix, something like that, ing, which are removed while we are doing some stemming or something like that. Okay. Then semantics. If we are saying that semantic of a word, that means meanings of words, meaning of text in the language. Okay, bag of words we have discussed in the last class. So whenever we are talking about bag of words, this means count, this means frequency, ignoring which word is coming first and which word is coming next. So ignoring the order of the words, it's just counting of words. Okay, so basically frequency. So bag of words is just a featureization where a vector of word counts is taken maybe in a binary form or maybe in the actual frequency of that is number of times that word is occurring in that sentence. Okay, so today what we are going to focus upon is n-grams, and next is part of speech. So n-gram is nothing, it's just a sequence of word. Now because in bag of words there were two disadvantages. First was vocabulary size was too large, and second, first was vocabulary size was large, but it was a basically sparse matrix would be generated, right? And the second disadvantage was sequence of order is not considered, like which word is coming previous to the next word, that sequence is not considered. So to remove this disadvantage, n-gram came into picture. So here it is basically sequence of n words. So it can be two words, three words, four words, five words. So set of few words, and then we use that set as input feature. Instead of considering one single word, we just consider the that set, basically that sequence, that short sequence, maybe sequence of two words called a bigram, sequence of three word called a trigram, and sequence of one word called a unigram. Okay, so that is a n-gram approach. So let's see how it is useful and where it is used. So I'm going to discuss about language modeling. So let's see. So in language modeling, basically we want to estimate the probability of occurrence of a sentence. Sentence is just a sequence of words, okay? And we want to calculate the probability of occurrence of that sentence in that corpus, that this sentence will appear or not. And also it is useful in predicting next word, like what is the probability of predicting next word in the sequence. Suppose I am saying hello, how are you? So if I have hello, how I are, hello, how are, this these three words I have, hello, how are. So what are the chances of you occurring next to hello, how are? Okay, so this is estimating the probability of next word given the previous three words. Okay, so these things can be done using language model. Besides this, there are many applications, auto-completing sentences. So given that Lynn is eating, so what are the chances of occurrence of a chocolate? Okay, so what is the probability of occurrence of this word chocolate given that Lynn is eating? So we have to train the model on past history of Lynn, right? So this way, this is one of the application of using these anagrams. So we'll see how these anagrams are used for this. Okay, so another application is maybe speech recognition. So in speech recognition, suppose someone is saying something, suppose someone is talking about I. So I can be part of a body, EYEI, and someone is talking about I, so it can be me. So there are two meanings of I. Okay, so in a sentence, suppose I'm speaking, I'm writing this. So definitely that EYEI is not there. It is this sentence means that I'm talking about myself. I'm writing something. Okay, and second thing is if I'm saying like uh, uh, his eye is of black color or something like that. So it's not I, that eye is not, I'm not talking about me, I'm talking about that body part, right? So this is speech recognition. So what is the probability of occurrence of that word I? Either it is a I or it is a EYEI. Which word is it given the whole sentence? Okay, so this is speech recognition. Next is spelling. So in spelling also, suppose someone is typing a sentence, and what is the probability that that a word, a single word, or that sentence is typed correctly? Okay, so that is spelling correction. Again, augmented communication, this is very popular. uh, so in this, basically, while someone is doing some gestures, some system is recognizing human gestures, and it is creating a list of dictionaries. Okay, based on those gestures, it will tell you a set of words that you want to speak. For example, Stephen Hawking's, you might have known that he uses this technique where what he wants to speak is communicated by machine. And how it happens is it basically recognizes the gestures and gestures of human, and it generates a set of words probability, and the word which is having highest probability is returned. Okay, so input is a series of gestures from the user, and uh, a set of words is generated, and out of which the word with highest probability is basically returned. Okay, so that means, okay, human wants to communicate this thing. This is called augmentative communication. Okay, so there are many more applications of this where these anagrams are used. So today we are going to see about language modeling. Okay, so these are the steps while doing language modeling. So first of all, we are going to see auto completion example. Auto completion means I have a sentence, hello, how are, and I want to predict you. So what are the chances of appearance of you in this whole sentence? Given these three words, what are the chances of appearing you? This is called auto-completion. So here, first thing is we have to transform this raw text corpus. So this is first sentence, second sentence. We have so many sentences, and using this, we have to convert it into a n-gram model. Okay, so we have to convert this into a n-gram order. And then what we have to do is, so today we are going to see this part, how we are going to convert this into a n-gram language model. And second is out of vocabulary words. What happens while training this whole data set is, while training, during the testing time, it might happen that certain words which are not in the vocabulary of training data set appear. So how to handle them? So we'll also see how we can handle those are called out of vocabulary words. So those words, because a model requires something that it has already trained upon. So what about those words which model has not seen already? Okay, so we'll see how we can use them out of vocabulary words. Next is smoothing. Smoothing is done, and why it is done? So it is a step-by-step procedure how to build this auto completion model. Then smoothing is performed, and then language model evaluation. We'll see how a model is evaluated. So let's start with first part where we are generating n-grams from the text corpus that we have. Okay, so n-grams. So basically it is a sequence of n words, and these n words can be like unigram, bigram, trigram, and so on up till 5. Generally we do this. And why do we do this? This is very important because, okay, let's look at this example. So if I talk about bag of word model, so what happens is the mat sat on the cat. This is a sentence, and in the vocabulary size of maybe 14 words, 1, 2, 3, up to 14. So the mat, the was appearing on the first place, mat was on the 14th place, sat was on the 5th place. Okay, somewhere here. Okay, so this is my vocabulary. So if I do bag of word, it will give me, okay, this was on, so vector would be, because this is vocabulary size was 14. So the uh, mat was up, basically these words are representing in the form of vocabulary. So if the is present 2 times, so over here, this is the frequency count of the. Okay, last is mat over here, so mat is appearing once, so over here. So size of each and every vector in the sentence, if I have 5 sentences, so first sentence would be represented by this vector, second sentence would be represented by some other vector of same size. Okay, so you can see there are so many zeros over here. Okay, so this is bag of words. But here the thing that is lost is sequence. You can see that the word which is appearing first, it can come before or afterwards. So sequence is not retained, right? So this is so that is why n-gram came into picture, which capture the consecutive words. So if I talk about unigram, it will take definitely single word. If I talk about bigram, it will take 2 words. The mat. Okay, we'll see how. So this is bigram. So in bigram, so this is a sentence, the cat sat on the mat. So first bigram is this, the cat. Second bigram is cat sat. Third bigram is sat on, right, over here, and so on. So bigram is nothing, it's just consecutive set of words. Now there is one thing, if you can see that like sat on is giving me a better picture, or cat sat is giving me a better picture of what is happening in the whole sentence, right? Instead of I'm writing uh, the whole uh, single each and every word as a single word, maybe feature. So that is not giving me a better picture, while cat sat is giving me a better picture, like okay, maybe cat is sitting in the sentence or something like that, right? So that's why these bigrams are important. Similarly, if I talk about trigram, it will give me a even better picture, like what is happening in the sentence. It will make more sense, right? So in the trigram, if you see, so the cat sat, this is first trigram, sat on the mat. So on the mat. So this is even giving me a better picture. Maybe not in this sentence. Mat sat on is giving me a better picture. Second sentence was this. So here this is my second trigram, which is saying Matt sat on. So we are talking about, okay, Matt sat on the cat. So Matt sat on something. So this sentence is giving me even a better picture of what is actually happening. Okay, so that is why this is useful. Now, so I will consider these sets, these each and every set as a feature. Instead of selecting each and every word as a feature, I will consider these bigrams as a feature. Now I have a choice, like I can select bigram, I can select trigram for my model as input, anything, okay? Depending upon what kind of words you are expecting. Suppose I'm talking about the Taj Mahal, okay? So that Taj Mahal, if you write this as separate set, basically it should be a bigram, it should not be a unigram, right? Because Taj and Mahal, these are separately, don't make any sense, right? So we need a bigram to train this kind of model where we have words like Taj Mahal, Qutub Minar, something like that, right? So depending upon what kind of data we have, we'll use that kind of uh, subset in to as an feature to input to the model, right? So similarly, so we have unigrams, we have bigram, we have trigram. So advantage to use multiple n-grams is it capture the able to detect influences that are weak, while bigrams and trigrams capture strong influences that are more specific. For example, the White House. So White House will generally have a very different influences from the sum of influences of the White House, right? So the White House, so what it is saying is the White House combined make more influence, make more sense than the house separately, each and every word separately over here, right? So now you have choice. You can use ngram plus bag of word model to improve the accuracy. You have choice. You can use either 3 grams or you can use 2 grams, unigrams. You can use combination of unigram and bigram. You can use combination of unigram, bigram and trigram in your data set. Now, can anyone think of one disadvantage of doing all this?
It's like extremely competitive,
Sorry.
intensive.
Cannot understand what you're saying. You can type it. Computationally intensive, right? And how computational intensive? How? In terms of memory, space, execution time, performance of model. So many things are there.
Mostly memory because it has to calculate from all. If let's say if you're calculating 3 grams, then it
Hmm.
has to calculate. And if there are 100 words, that means it has 100 into 100 into 100 possibilities.
Exactly, exactly. So same thing, same is the problem with these. So if you have a vocabulary set size of, uh, you can see my screen.
Yes.
If vocabulary size of 100 we have, so what are the possible number of bigrams? 100 cross 100. And what are the possible number of trigrams? 100 cross 100 cross 100. So many possibilities that are there. So vocabulary size is even increasing. Okay. So this is a disadvantage. Now let's see. So, how these n-grams language models are used? So, n-gram can be used to build statistical models of text. We'll see how in the lab also we'll see, and in lecture theory also we'll see how models are built using these. Okay. So, first of all, we'll see the probability with each anagram is appearing in the model, and secondly we'll see the overall probability of occurrence of a sentence. So two types of probability we can calculate. So we'll see how these are calculated. So first of all, let's see how the notations that we are going to use. So if we have 500 types of words, 500 words in our corpus, so we'll write a subscript on the right hand side of each of the word. Okay. So 500 types of words were there. So number of words m is equals to 500. And if I'm talking about W1M, this means I'm talking about from 1 to m, all the possible numbers. Okay, so m is basically, if this, what is this? This is basically a trigram. So I am talking about a trigram. Okay, and in trigram we have three words like first, second, and third. So this is great. So this is a trigram. Okay, like this. So this is showing the uh, up till which value we are taking. For example, 1 to 3 means 1, 2, and 3. So this is a lower index and higher index. If I'm taking m minus 1 to m, so this is again a trigram with three words starting from m minus 1 from here to here. Okay, so this is index that we are going to follow throughout. So let's see, calculate the how to calculate the unigram probability. Unigram probability means what are the chances of occurrence of that word in the corpus. Okay, so what are the chances of occurrence of happy? I am happy because I'm learning. So how many words are there? 7. So size of corpus is 7, right? So what is the probability of occurrence of I? I is appearing first and second two times, so 2 by 7. What are the chances of occurrence of happy? Happy is appearing one time, so 1 by 7. So probability of a unigram is the easiest one to calculate, which is the count of that word appearing in the sentence divided by total number of words in the sentence. Okay. Next is bigram probability. So bigram is a little bit complicated one. Here we are calculating what are the chances of occurrence of I am given already I occurred. So am I and I am, these two are different bigrams, right? So what are the chances that am is occurring given that I already occurred, right? So what are the chances that am is occurring given that I already occurred? It is calculated by conditional probability, which is I am by given by I. So I is appearing two times, first over here, second over here. So I is appearing two times, so over 2, over here 2. Now I am together is appearing how many times? So first time and second time. So 2 by 2. Okay. Again, happy and I. So what are the chances of occurrence of happy given am is already uh, uh, given I is already there. So I happy. So they want to calculate the probability of occurrence of I happy. Now I has appeared twice over here. So count of I is 2. Over, first is over here, second is over here. What are the chances of occurrence of I happy together? So it's not there, so count is 0. Okay, so this is 0. So this is how we calculate the probability of a bigram. Now trigram is even more complicated. So let's see. So in trigram, what is the chances of occurrence of I am happy given I am already occurred, right? So chances of occurrence of I am happy is how many times this I am happy is occurring. So one time in the sentence, right? One. And given the I am already occurred is 1 and 2. So 1 by 2. Okay. And probability of trigram can also be written as probability of, this is bigram, right? Bigram plus a third word plus one more word, which is W3, and this is again a bigram. Okay, so this is clear up till here. Any questions, anything? So prepare a numerical. Next week you are having a lab, sorry, a quiz on Monday. So prepare a numerical over it, okay? And if you face any problem, let me know in solving any numericals related to this. So n-gram probability. Now to calculate n-gram, so we have seen unigram, bigram, trigram. Let's see the probability to calculate n-gram, which is the count of n minus 1 grams that is already appeared and the last nth gram, right? And the count of n minus 1 grams again. So this is n-gram probability. Now let's see. So up till now, what we were doing were in the whole sentence. Suppose sentence was again, hello, how are you? So we were calculating probability of hello. What is the probability of hello given a sentence? What is the probability of how? Unigram. Okay. What is the probability of hello given how? So this is bigram. Okay, so we are just calculating the probability of words. Now we want to calculate what are the chances that this whole sentence is appearing in the corpus, right? So probability of sentences. Suppose the sentence is the teacher drinks tea. Now what is the probability? So probability of occurrence of the whole sentence is, if you see, so first of all look at this one. So if you remember bigram, so in bigram what we were doing was second word given the first word, right? Which is second word, and first word, right? So this is what we are doing. So this is conditional probability of occurrence of B given A, and this is joint probability of both of A and B. So this is joint probability, and this is conditional probability. Conditional probability, okay? So of both the words given A already occurred, right? So if you consider this as whole one word A and this consider this as B, now it becomes simple, okay? So basically joint probability of the occurrence of the whole sentence can be calculated from here, right? So they have written like joint probability of occurrence of whole sentence is equals to, if you move this term over here, now I can say that, okay, what is the probability of occurrence of A and B together? It is equals to PA into PB by A, right? So we can replace this like this. Now, so similarly, so we know this one, we know this formula, right? So using this we have derived this. What are the chances of occurring of, now we are not satisfied with the two words in the sentence, we want to calculate the probability of occurrence of four words together, P A B C D. We want to know that what are the chances of these four words, or maybe these four words are together, or maybe sentence having these four words is present or not, one and the same thing, right? So whether that sentence is sentence with the four words A B C D is present or not. So this is calculated as, again this chain rule is applied over here. P A given B already occurred, P C given A and B already occurred, PD given A, B, C already occurred. Now these things are required because we want a sequence. If we want it randomly, whether A occurred, B occurred, C occurred, or D occurred randomly, then this part would not be there, right? We want conditional probability. We want like A appeared given B appeared given A appeared already in the sentence. C should appear given A and B. The teacher already appeared, then only I want whether drinks appear or not, right? And this fourth word says, okay, T appeared given the teacher drinks appeared or not, right? So this is conditional probability. So this is called chain rule, and this is how we calculate the probability of occurrence of a sentence. Okay, so this is clear. Prepare a numerical on this, okay? So this is here, it's written, the teacher drinks tea, the teacher given the drinks given the teacher, tea given the teacher drinks, okay? So this is the probability of sequence. This is how we calculate the probability of a sentence. Now the disadvantage that we have already discussed is, suppose vocabulary size was V. Okay, vocabulary size was 100. So number of bigrams would be 100 cross 100, and number of trigrams would be 100 cross 100 cross 100. So this poses a challenge. Feature set size is increased. But what happens is, uh, if you have a large text corpus, so most if you have very large number of sentences, so most of these n-grams would appear. Okay, but if you don't have, you have a short data or short raw text, in that case you will not be having those common n-grams. Okay, so this is the disadvantage. So generally you may see values like this. So definitely unigram dictionary would be smaller, bigram would be even larger, and trigram would be even larger. So that's it for today. So we have seen like how n-grams are processed and how probability of occurrence of a sentence is calculated. In next class we'll see how this is modeled. Okay. So you have to study this skip grams. What is skip grams? You have to read. We'll do a short, short discussion over what is skip gram in next class. So that is it for today.
Got it.